In this lesson, we're going to talk about twisted pair network cabling. Now, twisted pair network cabling is very similar to the type of wiring that's probably used to wire the telephone system inside your home. Twisted pair network cabling is extremely popular. More than likely, if you get a job as a network administrator, twisted pair cabling is the medium you're going to be working with. It's supported by a whole bunch of different networking standards. It's supported by Ethernet, it's supported by token ring, and many others as well. Now, twisted pair wiring is composed of pairs of copper wiring, usually 22 or 24 gauge, twisted around each other. Let's take a look. A typical piece of twisted pair wiring has 22 or 24 gauge copper conductors, each wrapped in PVC insulation. Now, the unique thing about twisted pair networking cable is the fact that the wires are actually twisted. This is done for a very specific reason. When you run an electrical current through a piece of copper wiring like this one, a little bit of the signal actually leaks out through the insulation and creates kind of a ghost image of the data that's on the wire. That can be a problem when you have a second or third or fourth or fifth wire in close proximity. If you run a current through one of these wires, such as this one, and it creates a ghost current that's radiating out from this wire, this second wire that's near it can actually act like an antenna and absorb the signal from this first wire. That can be a problem with network communications because you have a signal on this second wire as well that you want to get between the hosts. If it absorbs the signal from this other wire, the data that was on this first wire gets corrupted. You don't want that. We twist the wires together because the twisting action causes this ghost signal to cancel itself out. You want to understand why? Go talk to your physics professor, talk to him about the way electromagnetic waves work, and ask him about destructive interference. There's constructive interference and there's destructive interference. In this case, we have destructive interference. The ghost signal cancels itself out. That means the data on both wires can arrive intact. Now, when you go down to the computer store and you purchase a segment of twisted pair wiring, if you open up that piece of twisted pair wiring, you'll see that there's actually more than one pair of wires in there. Most twisted pair networking cabling has 4 pairs within its PVC sheath. Now, as I said before, twisted pair wiring is extremely popular. It's got some excellent advantages over coaxial network cabling. Number one, it's extremely flexible. You can make twisted pair wiring go where coaxial cable would never have gone. The next thing is the fact that twisted pair wiring is much less expensive than coaxial cabling. We're talking less than 10 cents a foot. If you buy it in large bulk, you're down to 2 or 3 cents per foot. Because it's flexible, it's also really easy to work with. It's a joy to install compared to coaxial network wiring. And the biggest thing, the reason why twisted pair became so much more popular and widely implemented than coaxial, is the fact that newer, super fast networking protocols and standards were designed to support twisted pair wiring. It doesn't come without any disadvantages. There are a couple that you have to be really careful of. Number one, because the casing, the sheath around the twisted pair networking cabling is relatively thin, it doesn't have that second insulator like coaxial cabling has, it is quite a bit more susceptible to electromagnetic interference. Places you could run coaxial cabling without having interference, well, it might cause interference with twisted pair wiring. It's quite susceptible. If you have the right equipment, and if you have a mindset that's bent to do so, you could actually pick up some of those ghost signals and capture it and see what data is being transferred on that twisted pair wiring. So there are some security concerns. Like I said, coaxial is a little bit more resistant to eavesdropping. Twisted pair is a little more susceptible. Now, there are actually many different types of unshielded twisted pair wiring. By the way, unshielded twisted pair is usually denoted by the acronym UTP. If you see the term UTP, we're talking about unshielded twisted pair. Now, the main difference between the different categories of UTP is the quality of the copper that's used to make the conductors and how tightly twisted the wires are together. The tighter the twist, the higher the bandwidth that the wire can support. The first type of UTP you need to be familiar with is called Category 3, more often denoted in the industry as just Cat 3. Category 3 wiring is the oldest type that's on the Network Plus exam. It's about 10 years old. It was designed to be used with 10 megabit Ethernet or 16 megabit token ring. Cat 3 was replaced in the later 1990s with Category 5. Now, Category 5 supports 100 megabits Ethernet or 1 gigabit Ethernet, and it's also used with certain types of ATM networking. There's a variation on Category 5 called Cat 5e. It's very similar to Cat 5, but it offers better protection from the electromagnetic interference, and it's used with 1 gigabit Ethernet and 10 gigabit Ethernet. The last one you need to know is Category 6. Category 6 is very similar to Category 5, but it's designed to support very fast, high bandwidth broadband communications. Now, an important point to remember is that if you have a specification that requires, say, Category 3 wiring, you can use Category 5, Category 5e, or Category 6. It's backwards compatible. If you have a specification, however, that requires Category 5, you cannot use Category 3, but you could use Category 5e or Category 6. Now, for your Network Plus exam, you need to be familiar with two different types of connectors that are used with UTP cabling. The first one is called the RJ11 jack. This is this one on the left. The RJ11 jack has 4 connectors and supports up to 2 pairs. It has a locking tab to keep the connector from coming unplugged in the back. RJ11 connectors are used primarily with telephone wiring. They're not widely used with network cabling anymore. The one that is used for network cabling is the RJ45. That's this one over here on the right. RJ45 is used for Ethernet and some token ring connections. It has 8 connectors, so it supports up to 4 pairs of copper wires. And just like an RJ11 connector, it has a locking tab to keep the connector from coming unplugged. So that's twisted pair network cabling. Remember the following facts. Remember that twisted pair uses wires, copper wires inside a cable sheath that are twisted together to reduce electromagnetic interference. Remember that there's 2 different types of twisted pair cabling. There's shielded twisted pair and there's unshielded twisted pair. Within the unshielded twisted pair category, there's several different types of wiring. There's Category 3, Category 5, Category 5e, and Category 6.